Hey guys, this is video 13.2. So in the last video we talked about the reaction process, kind of talked about reaction mechanism, collision theory, all that type of stuff. Now we're going to talk about the reaction rate factors. So there are 6 factors that affect the rate of that reaction process that we talked about. So we're going to jump right in. One thing I encourage you guys to do after we go through the notes, I highly recommend to make flashcards to have the factor listed on one side and then how and why the reaction rate is affected on the other side. So it's a really big encouragement to help you guys study. It's a good study tool because I guarantee you will be asked questions on the regions like this. So let's jump in. First factor, nature of reactants. Okay, so what that means is their state of matter. That's the way to kind of think about the nature of the reactants, because not all states of matter are going to react the same way. Some will react faster than others, okay? But not only is it the state of matter, it's also the type of bond that takes place, okay? So the type of substance, i.e. ionic versus covalent. So ionic substances react faster. Now think about this. Why? Why do you think ionic substances might react faster? Well, one, they have ions, right? We know that they break up into ions, so ions typically are smaller than compounds that stay together, all right? So what that means is that ionic compounds, guys, tend to be smaller, okay? There are less bonds to break, which means that there are going to be less steps. So something, for example, and I'm going to write it, you guys can try to fit it in the space, but if you need to move over here like I'm going to, go for it, okay? If we have something like NaCl aqueous plus silver nitrate aqueous, all right, and then they form sodium nitrate aqueous plus AgCl solid. All right, this is a one step, right? Because most of these, wherever you see aqueous, I'm going to use a red star, okay? All 3 of those compounds, guys, they're already split up. Okay, they're not bonded to each other because they're aqueous. They're soluble in water. So they are already in their ion form. The only thing you have to do is that the silver ions react with the chloride ions, and that's a one-step process to form the bonds that make silver chloride. So that's a one-step process because of ions. Okay, so they're already broken apart in their ion form. Well, if we take a look at covalent substances, and I'm going to do these just in purple, just to kind of split them up in case I overstep a little bit with space. Covalent compounds tend to react slower. Why? Because they're larger. Okay, these are like your maybe you've heard of like lipids and proteins and things like that are in the body. These are huge, long carbon chains. We'll talk more about some of those things that I just listed off at the end of the year when we do our organic unit, but they're much larger. Well, if something's larger, that means there are more bonds to break, which means there are going to be more steps, because not only do you have to break the bonds, you have to then reform the bonds. So something like this, CH4 plus O2 gas yields CO2 gas and water, okay? But what you have to do here is you have to break 4 bonds, CH bonds. Then you have to break 1 OO bond. You have to then form 2 carbon to oxygen bonds and 4 OH bonds. Okay, so there's a whole lot more going on there because you don't have the ions. So ionics will be faster because of those ions. So remember that, guys. Ionic ions, they already have the charges, so it's less work. All right. So yes, state of matter plays a part, guys, but the type of substance is the bigger thing. Whether it's ionic or covalent, that's what you want to think about. Ionics react faster because they're smaller. All right. Factor number 2. And I might, as I'm going through this, we might split this into 2 videos just to make it shorter. Factor number 2, concentration. Okay, concentration. Well, just as a review, guys, what is concentration? So the concentration unit that we used was molarity, right? So that's moles over liters, okay? So think about it. If I increase my molarity, what's that going to tend to do to my reaction? It's going to increase it. So if I increase, my concentration, I'm going to increase the reaction rate. It's a direct effect. Okay? Why? Why would this be the case? Take a look at these pictures. Lower concentration here, higher concentration on the right. Well, look how many particles you have here. You have a lot less, so there's a lot less interactions. But the more particles you have over here, the more interactions. And they're going to bounce into each other. The more bonds are going to be broken because they're hitting each other. All right, so the more particles in a given space, then the less space between the particles equals more collisions. And that's the key here. I'm going to highlight that. All right, and I'm going to actually go back up here, guys. Ionic are smaller, so they react faster. Covalent are larger. I encourage you guys to highlight it as well. I have highlighters you can borrow if you need it. But the more particles in a given space, the more collisions. So more particles, more collisions. That's the key you want to take away from it. And that's a good picture right there that's included in your notes to help you get a visual of it. All right, factor number 3, pressure. We're going to put a star next to this one, and you'll see why in a second. All right, so pressure. Think about it again. Pressure, if I have a piston, okay, that looks something like this, so I have particles out here, and then I compress that, okay, so I change the volume, which means the pressure goes up. Well, look how much tighter those particles are going to be. So if I increase the pressure, what's going to happen to the reaction rate? It's going to increase as well because, again, those particles are getting closer to each other. The closer the particles are, the more collisions. So think about it in terms of collisions. The closer they are together, the more collisions are going to be. This only affects gases, and that's why we started, okay? This is only gases because they're the only thing that has a pressure. Excuse me. All right. So if we increase pressure, kind of what I already showed with that picture. Oops, sorry. All right. That means you decrease the volume, Boyle's law, which decreases the space between the particles, which means, again, more collisions. That's the key there. You want to have more collisions to increase that rate. So increase pressure, more collisions because the space is decreasing. All right. So I'm going to, just for the sake of time and making this video not too long, we're going to pause this one and we're going to pick it up in the next video, the other 3 factors.